Alright, welcome everybody to CCNA Scaling Networks version 6. Today we're going to look at Chapter 7, EIGRP Tuning and So we're going to look at summarization, problems it can have and the benefits it can have. We're going to look at how we get default routes. We're going to look at improving performance. We're going to have a look at authentication. We're going to have a brief look at different types of troubleshooting. So, automatic summarization. Not normally a big deal, but it can be a big problem. So we've got 172.16.00/16, that's the whole network. But actually, on that side of the network, on the left, on router 1, we've only got 3 subnets. So when router 1 wants to tell router 2, it doesn't actually say, hey, I've only got 3 subnets and a /30 of 172.16. It just says, oh no, I've got a wacky discontinuous subnet, so I'm just going to summarize it to back to the good old class system and say that I've got all of 172.16.0.0/16, and this can cause some weird problems in your network. So automatic summarization used to be enabled by default. It used to be enabled by default, but Cisco realized that 99.9% of the planet have say no auto summary. They turn it off by default. So in version 15 and 12.233, Cisco said, all right, fine, let's turn off automatic summarization. Turn it off. It does more harm than good, so we'll turn it off. So if you want to turn it on, the command is auto summary. If you want to turn it off, the command is no auto summary. So, but I would typically have in your journals, I would have router EIGRP and a number, and I'd have no auto summary in there. Just type that command automatically because it'll save you lots of grief. And if you want to verify, the best command, show IP protocols. Very useful command. Do we even want automatic summarization? Sometimes it can be a benefit, sometimes it will be a curse. And let's have a look at some examples of that coming up. The easiest example I can give you is if you design your entire network around 172.16 something something, then you can leave automatic summarization, and EIGRP is quite happy to sort it out. But the instant you add another class in there, so maybe a 192.168 or a 10 network, that's what breaks automatic summarization, discontinuous subnets. So let's have a look at how we work around that. But before we get to that, let's have a look at topology. So in this example, it says we've got 172.16.0.0 is via 2 different paths. Now this is a bit of a notice that doesn't really meet the feasibility condition. So that's what the all links is for. If you just do show IP EIG or topology, it shows you the successor and the feasible successor. But if you want to see all the links, regardless of whether they're successful or not, you just add the word all links on there. So here's the example. So show IP route EIGRP with automatic summarization disabled, we see 3 networks. Notice that those 3 networks, one is via serial 0, one is via serial 1, and we're not sure where the third one is, but it's probably, it's via serial 1 as well. Now with automatic summarization enabled, it's gotten confused, and it now thinks that all of 172.16.0.0/16 is all via serial 00. But as you can see from the above slide, 172.16.2 and 172.16.3 are via serial 001. So therefore, the network's going to go in a strange direction. It's all because we've got a mixture of 172 and 192.168. That discontinuous subnets, putting those random subnets in the mix breaks everything. When you're going to do that, disable automatic summarization, and then EIGRP will just advertise what it's meant to advertise. Here's another example of the problems with automatic summarization. So over here we've got 172.16.1, 2, and 3 on router 2, and router 2 says, oh, actually I've got all of 172.16.0.0. So that when router 1 learns about it, he says, oh, hang on a minute, I've got to get all to 172.16.0.0 this way. So if I need to get to, let's say I want to get to 172.16.99.99, router 1 says, oh, how do I get to that? Oh, router 2, he knows that. So you get it, he gives that to router 2. And router 2 says, oh, I don't have 172.16.99, so I'll use my default route and give that back to router 1. Router 1 says, oh, hang on a minute, 172.16.99, that's behind this summary route, that's on R2. So that traffic will just bounce between router 1 and router 2 up to 255 times. You don't want that. That's bad. So what we can do then is now on router 2 we say 172.16.00/16, that's rubbish. Throw it away. But remember that routers route longest mask matching. Therefore, 172.16.1.2 and .3, they're going to survive. They're going to get to router 2 and everyone's going to be happy. As soon as a packet comes along and says, I'm looking for 172.16.99.99, router 2 gets that packet and says, I know what to do with that. Chucks it straight in the rubbish bin. So therefore the routing loop's now gone. You still have the summary, which is not ideal, but at least now the routes to unknown 172.16s get swallowed up and eaten up and chucked away. But summarization doesn't always have to be a bad thing. We can do summarization manually. So here we've got 192.168.0.0 and we've said, actually, you know what? This is going to cover 192.168.0, sorry, 192.168.1, 192.168.2, and 192.168.3. So now when router 3, he's pushing the route up to router 1, and he comes across and says, you know what? That's a /22 now. Of course, you've got to make sure that you don't have 192.168.0 anywhere else, because a /22 is actually summarizing 4 networks, not just 3. This is also, because we've gone beyond the class boundary, we can also call this a supernet, because we're no longer obeying the rules of the class system. The interesting thing about manual summarization is the way the router trusts that information. So this is important, on the router that is performing the summary, the administrative distance of that summary route is a 5. But everyone who learns about that summary route learns it normally as a normal 90, the administrative distance of 90. So everywhere you manually configure a summary, it marks it as a 5. It marks it as a better or a higher, more trustworthiness than things that have been learned dynamically. So the administrative distance for a manual summary route is a 5, but on the router you program it on. All the other routers that learn about it dynamically learn it as a normal EIGRP 90. It's all to do with perspective, and that's why they got those two people looking at a number 6 and a number 9 arguing about it, whether it's a 6 or a 9. It's the perspective. So summary routes on the router you're on are a 5. Summary routes learnt on other routers are 90. Propagating a default route. This is what we had to do with RIP and RIP version 2 back in the good old days, and they very recently added that lovely command that I love, default information originate. But we have to go old school on EIGRP. So, and I can well imagine that in the coming years, maybe 15.2 or something like that, default information originate will work in EIGRP. But for now, we just have to do redistribute static. So we set up our static route to the world, 0000000, the exit interface and the next hop IP address. We go route EIGRP1 and we say redistribute static, because IP route's a static route. The downside is, if we've got 20 static routes, all 20 of them will be redistributed into EIGRP. And that's why default information originate is a far more better command. But we're not there yet. Now, interesting thing about redistribution. EIGRP knows what it likes that's pure EIGRP. So if you're doing redistribution, technically that's an external process that's being sucked into EIGRP. So now the administrative distance of an external route is 170. So a summary on the route you're on is a 5. Everything else is 90 unless it's been learned from outside the EIGRP process. So redistribution of static or redistribution of any other routing protocols, they're going to come across as 170. The administrative distance of 170. And they've also got this lovely little EX to say they're external. And because it's a default route, it's got a little asterisk. The asterisk representing that it's a default route. IPv6, once again, exactly the same as IPv4, just the syntax is different. So for an IPv6 default route, it's IP route, all zeros, /0. And remember, all zeros can be compressed into just a double colon. So that's it. That's the default route. IP route, /0. And then redistribute static. Now, if you're on a really old router, sometimes they complain. Sometimes they want all 5 K values so it can actually do the math. Bandwidth, delay, reliability, load, and MTU. That's the actual equation that it needs. Even though only bandwidth and delay are used, it still might want all values. So if you type redistribute static, doesn't quite work the way you want, just do redistribute static and put in 5 values that you want that redistribution to be taken into consideration. Now Thymus. Like all good routing protocols, you can play with the Thymus. There's your defaults. 60 seconds on slow links, 5 seconds on fast links, and the whole time is a factor of 3. Now you can play with those timers. However, these timers, if you set one router with weird timers and the other router's default, strange things are going to happen. So I strongly recommend either leaving the timers alone altogether or making very careful choices that where you set those timers, you make sure you set them everywhere. Now this is about 5 slides compressed into one, so we've got a few things to work about. So router EIGRP 100, we have 5 network statements. Now looking at the way those networks work from left to right, we've got, if we go via router 2, we've got feasibility distance of 30, reported distance of 10, router 3 is 20 and 10, router 4 is 45 and 25, router 5 is 50 and 10. So right now there's only one best path. There's only one best path, and that's via router 3. Router 3 is the best, fastest path to go from side to side. But let's say we want to set up unequal cost load balancing. By default, equal cost load balancing, that's always there. 2 paths the same, they'll be load balancing. But let's say we want to use unequal costs. So what we could just set is the variance command. Now be very careful because the variance command is a multiplier. So what we've said there, variance 2, that means the current best path another path can be up to twice the metric of that path and still be considered to be good enough to use as an equal. So if we set the variance of 2, then you notice that router 3 of 20, double that is 40, so therefore router 2 via the top would now be considered equal. So now with a variance of 2, network traffic would move from left to right through 2 routers, through router 2 and router 3. Now if there's TCP traffic, it'll probably be okay, but if that was voice or video, packets would arrive out of order. So, you know, is it a good thing, is it a bad thing? The only time you'd ever really use the variance command, in my opinion, is where you've got 2 links that are almost the identical speed, but for some reason their delay has given them just that few percent, like 0.1% variance, so therefore it thinks that it's no good. But you know that you've got 2 10 meg links, but one of them is actually 9.99999 speed and the other's 10. So having a variance of 2 will probably work out. But if we said variance of 3, then that would be 20 times 3. So therefore, all 4 routers would be used load balancing from, load sharing. No, actually, no, load balancing. Load balancing from left to right. And with some of those links being a lot slower than the others, your voice and video traffic would get pretty funky. But you can also tune that with the maximum paths. By default, equal cost load balancing has a maximum path of 4. So if you want to do unequal cost load balancing, you can trim that. Say, you know what? Maximum path 2. So if we said maximum path 2 and variance 3, all paths could be utilized, but it would still choose only the best 2. So variance is a multiplier, maximum paths is the amount of. So if we had 4 or 5 purely equal paths, maximum paths will say, no, only use this amount of paths to get from there to there. Authentication. Now this is a bit of a curly one, so we're going to have to spend a bit of time on this, but authentication is all about setting up keys and key strings and then using those key strings and key chains. So let's have a look at how EIGRP sets up its authentication. So, first of all, the thing you have to do is set up a key chain. So EIGRP underscore key is the name of the key chain. Key 1 is going to have a key string, Cisco 123. Now, in the interfaces, we're going to send EIGRP key chain as a value. Now, this is the thing that's a bit of interesting. The key chain names, or the names of the chain, do not have to match at each end. However, the numbers do. So let's say you'll work at a big convention center. Oh, and on the previous slide, it's all MD5 hashed. So you work in a big convention center, you got one router with 20 interfaces. So you go through and you set up 20 different keychains. And then you go to interface 7 for customer 7 and you say, you know, IP authentication key change EIGRP 101, EIGRP underscore key. But the customer who's in booth 7, you have to tell them to say when they configure their end, they have to set up their keychain and they have to say key 7 and then the string. That's what I'm saying. The key numbers have to match. So if I set up 2 routers with the same keychain name and I say key 1 on the left hand router and a string, but on the right hand router I say key 99 and a string, it'll never work, because the actual number of the key is an important factor in the MD5 hashing algorithm that tells it which key string to actually use. So the name of the chain is meaningless. It's just locally whatever you want. But the number of the key, the number of each individual key, must match at each end. So, quick look at troubleshooting. Do we have neighbors in our neighbor table? Very important. Things that will kill neighbors could be the wrong subnet, bad IP addresses, or bad timers. So, show IP interface brief, show EIGRP neighbors, show IP EIGRP interface. Let's say we got some neighbors, but the routing table is not quite right. Are we advertising the right networks? Do we have an access list blocking certain things? Do we have weird subnetting? How do we figure that out? Show IP protocols. Best command. Should be using that all the time. Show IP protocols. And of course, show IP route EIGRP. So let's say we've got a big table full of stuff, but traffic's going a weird way. Show IP EIGRP interface. Maybe the metrics or the bandwidth command is not quite right for a specific interface. Layer 3 connectivity is an absolute 100% prerequisite, because these routers must be able to talk to each other with those hellos. Those multicast hellos must make their way. So the source and destination addresses must be reachable. So if you have R1 and R2 on different subnets, EIGRP will never work. So the very first thing you must always do If EIGRP is not working, just send a ping. Can R1 ping R2? Yes or no? If it can, then there's something else wrong. If it can't, then you got to fix that first. Passive interface. Some people put the passive interface command on the wrong interface, and therefore that's why the neighbor adjacency doesn't form. Because remember, passive interface, you can learn, but you're unable to speak. Passive interface, nothing leaves that interface. So you got to make sure you do that properly. Missing network statements. Classic. Classic miss. Forget to advertise the right network. So on router 1, we're advertising 192.168.10 and 172.16. But there are other networks. The other guys need to know about our other networks. There should be a 10 network. So just go conft router EIGRP1 and network 10. Press enter, and within a few milliseconds, because EIGRP is event driven as well, so when things change, then everyone's going to learn that information. That's why, once again, show IP protocols. Great command. Alright, what have we learned in Advanced EIGRP? Great routing protocol, lots and lots of features. Summarization and automatic summarization, big deals. You got to be really careful with the way you treat summarization. So best practice, just pick a class A or B subnet and chop it up. Try not to have discontinuous subnets. Alright, thanks for your time, and we'll see you in the next one.